Okay, so, right, so there's, the general name is basically a hash map, but it's called different things in different languages. And so in Python, for example, it's called a dictionary. I think it is called a hash map in Ruby. In PHP, it's called an associative array. Like everything has different names for it. But it, and I have not studied JavaScript memory, so I don't know if objects in JavaScript are all officially hash maps. But the idea about hash maps, yeah, and actually let me just do a tiny bit of research live on that. So, oh, am I sharing my screen? No, I think I am. Usually I'm used to getting like the green like glow around the edge of the screen when I'm sharing. Okay, so are JavaScript objects hash maps? Oh, no, JavaScript has something called a map. True hash maps in JavaScript. Okay. Why not hash objects yourself? Okay. Oh man. Okay, this is like they're recommending that somebody make their own hash map. But oh man. Okay. I'm tired of that one. Let's see what we have here. Every JavaScript object is a simple hash map. JavaScript objects cannot be implemented purely on top of hash maps. Okay, let's see what this is. Holds key value pairs. Objects and maps compared. Okay. Objects are similar to maps in that they set keys, blah, 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 detect whether something is stored. Because of this, and because there were no built-in auto-turn, objects have been used as maps historically. There are important differences that make map using, okay. An object has a prototype, so there are default keys in the map that could collide with your keys if you're not careful. Interesting. Okay. The keys of an object are strings and symbols, whereas they can be any value for a map. You can get the size of a map easily with the size property. I'm just wondering. Yeah, none of this is talking about memory or the runtime. So I'm going to have to maybe do a little bit more research to know. I know how things are stored in Python. I just don't know how things are stored in JavaScript in memory. And the reason that an object literal is not a true hash map. Okay, so it's talking about the prototype. It's talking about inheriting from the prototype. Yeah, none of these are talking about memory or runtime. Okay, so here's the deal. I'm going to just talk from a Python perspective right now because that's what I know. So hash maps in general. So hash maps store key value pairs, but the reason they are so powerful and where the hash comes from is how they are stored in memory. If you have a list, I'm going back to Python because that's what I know. Yeah.
This is kind of a high level description of hashes. I don't even know it.
Yeah. So I'm going to, exactly. I'm going to talk about how they're stored in memory basically, and which is what distinguishes a hash map from a list in Python, a dictionary from a list in Python. So if you have a list, basically it is fast So basically the way a list is stored in Python is absolutely different for an array in JavaScript, that I know. A JavaScript array is really just an object whose keys are indexes. But in Python, the way that lists are stored is that there's all this continuous space in memory. So basically, I know that it's not nice for the recordings if I use the whiteboard, but that's how I know how to do this. So basically, when you make a list in Python, you have, it makes all of these, it sort of reserves all of these blocks in memory, and they're all the same size. So, which is what makes it really fast to go right to the fourth item, because it just can calculate where that is, because it just needs to go 4 times whatever size you've allotted. It's fast. We haven't talked about runtime at all, but it doesn't matter how big your list is. You can get to any index in the list in what we call constant runtime. It doesn't matter how big the list is. It takes the same amount of time to get to the first item as it does to the millionth item, because it's all just like calculating math and then going right to that space in memory. But with lists, if you want to know if an item is in your list, that you have to like look at every item in the list and compare with the thing you want to know about. There's no other way to do it. So that is going to be a lot slower if you have a list that's 1 million items than if you have a list that's 3 items. Hash maps work differently. The way hash maps work is you have a, so there are key value pairs, and basically here's like the start of the hash map, and then you make a hash of the key. So so let's say you have Apple, and you use some algorithm to make a hash of it to get a number, and that number tells you where to look in memory. So you can go directly from Apple to a place in memory, again, in constant runtime. It doesn't matter how big your hash map is. You just, it's just the way hash maps work. You can go from a key, you can go directly to a value. You also can tell whether or not a key is in the hash map by whether or not, yeah, so I think when you, this is a minor detail, but I think, you add hashes here and it gives you the key and the value. And then you have to deal with some collisions if 2 things hash to the same thing. But so if you, yeah, and then if you want to know if something is if there's a key in your hash map or not, again, because this hash tells you where to go in memory, you can tell, it doesn't matter if there are 1 million things in your hash map, or 3 things in your hash map, it takes the same amount of time to tell whether a particular key is in there. You just look in that place in memory, it's like, is the key there? No? Then it's not in the hash map.
It's the key is stored in like or something like that?
Yeah, it's sort of a more complicated version of alphabetical order. Basically, each key is hashed or sort of mangled into a number that represents a location in memory. But yeah, it's sort of similar to alphabetical order, except that you don't have to, even if it was alphabetical order, you'd have to do some sort of binary search to like find what you needed. Whereas here, you could actually just go straight there because you know the key, you know what it hashes to, and there you are. It's a pretty abstract concept. But yeah, but that's so. Yeah. So hash maps are very advantageous for runtime. They do things fast. And sets, so it sets in Python. There are JavaScript sets also, but sets have sets are like hash maps without values. So it really is just storing a bunch of keys. And so, so if you want to have a set of, I don't know, the learners at the Learners Guild, right? And then you can say, is this person a learner at the Learners Guild? If you were storing it in a list, Python list, you would have to look at every item to see whether or not the learner was, this mystery person was a learner at the guild. Whereas if you were storing it as a set, you could take the hash, see whether that set was storing something at that hash location. And even if the Learners Guild, ballooned to 6 billion people, you would still be able to instantly determine whether or not that learner was in the
guild. But the set is empty.
But you can add things to the set.
Okay. So then at what point? So the set is like a hash map without values.
So just keys.
Oh, it's got keys.
Keys, okay. But no values. Keys. Hash map has keys and values. Okay. Yeah.
And but if you add a value to the set,
it's just you can you add values, but they just I see. If you add a value, if you want to associate a key with a value, you can't do that. Sets don't allow for that. Then you need to use a hash map. Yeah, and JavaScript does have sets, and somebody was asking me in like my first or second week here about like an efficient way to do something. And again, like all I had was like, how to do it efficiently in Python. And I think I wanted to look up and make sure that JavaScript sets had constant runtime for, but I'm assuming they do. The other thing about sets is that you can't have duplicates. So, because everything is sort of hashing, just the same way you can't have duplicate keys in a hash map. You can't use Celeste to stand for one thing and Celeste to stand for another thing. You only get one key. You only get one value for every key, but the value could be an array, or the value could be another object or hash map.
Celeste. That's the last point to hash. Celeste with different names.
Yeah, sure. Yeah, if you wanted to do it that way, or you could just make each Celeste their own key, but then you could have Celeste point to. You can pretend this was 10 years ago, and you could make it point to her mobile phone and her home phone, right?
But you just said that you can't have different keys for the same name. So
right, or you can't have different values. So here I can actually do stuff with JavaScript. So if we're looking at JavaScript objects, and oops. So now if I say phone nums, I actually am preparing a lecture on JavaScript objects and prototypical inheritance for next week. Although I know I've been telling you like I'm preparing this lecture, and then I say, no, that's really more phase 2 stuff, but I'm planning on doing this one. Okay, so phone numbers.celeste equals, oops. Right, but then I have another Celeste, and her phone number is this. Right, what is the phone nums going to look like now? Yeah, just the last one, it clobbers it. Yeah, but if I want to say, like you say, I could say instead phone nums Celeste equals, and then I could say Santiago and then whatever, Jones. Right, and now that's okay. Mm-hmm. Well, again, I don't know if it's stored in memory as a hash map. I'm guessing it is, but I don't know for sure. It's key value pairs. And in order for it really to be a hash map, you have to store it differently in memory. Yeah, so, and then if I wanted like phone nums Celeste, then I can get it that way.
So just to recap, the advantage of the main advantage of hash maps is just their speed.
Yeah, and being able to store key value pairs, which you could do in a list in Python, but you could store it like right, and then you could parse it out yourself by splitting on the colon or something. But yeah, but the hash map sort of natively connects keys and values. Do you have any questions, Celeste? Did that answer your question? Yeah, you were asking about hash. Yeah, I think a hash table is the same as a hash map. Exactly. Let's just ask Google though. What's the difference between? Oh God! All right, I just need to like see between jam and jelly joke. I don't even want to know. Okay. A hash map class is roughly equivalent. Oh, this is in Java now. So yeah, except that it's non-synchronized and it permits nulls. Okay, I don't know what non-synchronized means. Okay, so Java. This looks like this is all Java doing this non-synchronized. So we can we were talking about Googling the other day, but minus Java means I don't want Java to show up in the results. Okay. You guys heard of Chegg? Neither have I. I don't think I trust it. Let's go. Let's go to Stack Overflow instead. Oh, do we trust Sweta? I'm going to go with Stack Overflow for now. Hash map, hash set, hash dictionary. In what language? Okay. They all mean a dictionary mapping unique, unordered keys to corresponding values. Okay, well, this guy got 2 upvotes, so I don't know whether I really trust them. Hash maps. Okay. This guy got 28 upvotes, but it's too dense for me to read. But apparently somebody liked it. Let's read this article. Ooh, Wikipedia. A hash table, parenthesis, hash map. Okay, so I think they're the same. But apparently a hash list and hash tree are different. You wish you had a hash tree? Sorry. It took me a minute to get it, but when I did, I thought it was very funny. Okay, so cool. Should we move on to shebang, or do you still have lingering questions? Okay. Shebang. Okay, so shebang is if I have a new, or if I have a file, I can run it using like Node and then running the file. Basically that I want to interpret it using Node, or I can use Bash and then run the file. I can interpret it using Bash, Python and run the file, Ruby and run the file, and so forth. But if I want the file to be an executable on its own, if I want people to be able to run the file without knowing what you need to do to run the file, that's where the shebang comes in. The shebang tells you what you want to use to interpret the file. So if we do, let's say I'm going to make a shell script. So you guys have done it with Node, so I'm going to do something else and make a shell script. So okay, and I'm going to touch, let's see, what do we want our shell script to do? I don't know. Touch, I'm just blanking on what I want the shell script to do. Okay, so touch, go home, and show date. Okay, fine. So, and it's typical to do .sh on the end of shell scripts. So a shell script is just a bunch of shell commands that you're running in a script. So go home, cd this, and show date. Okay, if you run the date command, it shows the date. Great. You could also do things like var, or not var, how do you say it? Set. I have not done a lot of shell scripting, clearly. And then we could say echo, which is print. Today is date. And we can also say your current directory is home. Yeah, but in a shell script, I'm just doing it's just sort of temporary to the script. But I am using the $home environment variable, not environmental. It's not like green or anything. Okay. Okay, so I can use Bash to run go home and show date. And it says your current directory is users presenter. Oh, and it didn't like my new line. And then today is, and it didn't like my date. Okay, so basically this is a failed shell script because it also didn't leave me in my home directory. So actually let's do a little bit more just quick research. Setting a variable in a shell script. Notice they're using the shebang. Variables. Oh, you don't have to use set. You just do the variable equals whatever. So, okay, and I'm going to do home files. Can you do that? Let's see. You can. Okay. So I'm going to say, and so then I'm just going to say, let's change it from go home and show date to show home and date. Okay, so now I'm going to say today is date, your home directory has these files. Whatever. So, okay, so let's actually, now let's bash that again. Cannot execute binary, oh, bash. Oh, and I could just hit tab. I knew there was only one file in this directory, so you can just hit tab and it's like, yeah, I'll give them that. Okay. Home files. Okay, so I messed up there, but today is date. Your home directory has these files. Have a nice day. So let's go back and see. I guess it doesn't like my spaces. Why can't I do an ls? Yeah, but I should be able to, see, you can do it here. I think that's just a string though. I don't think that's gonna do it. I don't think that's gonna, okay. So it really wants, it doesn't understand. Okay. Show date, okay. Oops. Okay, so fine. This is, we're not learning shell scripting here. Okay, today is date. Okay. Do I have to do something like this? Okay, all right. Sorry for my lame shell scripting skills. Apparently, if you want it to run something on the other side of an equals, you have to put it in backticks. But you don't have to if you, like, obviously, like it's running this line without backticks. So, all right, so yay, shell scripting. I'm so glad these are recorded for posterity. Okay, fine. So now I did, but in order to run that, that took way too long, but it was a nice little foray into shell scripting. In order to run that, I had to say bash. And if I just do showdate.sh, first of all, it says commands not found. Why is it saying command not found? It's actually, Celeste is closer. What would I do, Celeste, to make it not say command not found? Oh no, you actually no. Actually, I can. Simply adding the shebang will not solve that problem. Is it bin bash? Like it won't even let me do it. Oh, so the commit. Interesting. Why did I get permission denied versus command not found? Yeah, permission denied is because I didn't have executable. So why did this say command not found?
It's not
looking for commands in the directories where there are commands, and that's
What determines what directories have commands?
environment variable.
An environment variable. Thank you for not saying environmental. An environment variable. Which environment variable? You know? Yeah. So it looks for commands only here. I can say oh, why didn't you, why do you hate me so much? Oh, I think I have to do export. Different shells do different things. Okay, good. Oh, but let's, we actually don't want that, because now it's doing this weird thing here. I should have put a col in there. So I'm gonna solve this by opening a new shell, rather than try and fix it. Okay. Fine. Now it's going to look in dot slash. So if I, oh, it's, oh, I know why, but now it's telling me permission denied rather than command not found.
So, considering shells for show.
Now it finds it as a command. So before it couldn't find it unless I actually told it where. Now it can find it. So I've solved that problem. But now I'm getting permission denied. So how do I solve that problem? Chmod. Chmod what? Okay, yeah, so plus X will give me, everybody can execute it. 755, what does that do, Celeste?
It represents the permissions. It's binary numbers for each set of permissions. And so read, write, execute is 1, read is 2, and write is 4. So you have to add the ones that you want together, and then in order is like user, group, and program.
Yeah. So 1 is 2 and read is 4. Write is 2. Yeah, yeah. So if so basically if I say 755, that's equivalent of saying the first one is 7, which is 1, 2, and 4. So it's RWX. That's for the user. The second one is 5, which is read and execute, but not write. So, and the third one is also 5. So if I made the permission 666, what would that look like?
Actually, should the group permissions be except it's 5. You get 5? I'm sorry.
Yeah, no. I get 5 because the only way to get 5, these are binary, right? And so the only way to get 5 is to add 1 and 4.
So well, RNS. Okay, we have.
No, I'm glad you're thinking about it. So, okay, yeah. So if I did 666, it would be what? Yeah, and it's always RW, like that. And so 777 is all permissions all the time. But you can also do the plus X, which I often do because I can't be bothered to figure out the binary stuff. You can do U plus X. Dev, how's she doing?
She's not even ready halfway.
All right. Oh, wow. Okay. Yay, we get you another week. Okay. Dev's wife is about to give birth. So, okay. Right. So she had a doctor's appointment this morning. Okay. How can I see the permissions? How can I see the results of what I just did? Okay. So, and I did just a U plus X, which means if I just done a blanket plus X, everybody else would have been. So what would the binary be for this? This would be what number? 7. Okay, so, and then this would be what number? 4, and then 4. All right, cool. So, okay, so now I should be able to, I don't know why you're doing that to me. Did I close the wrong one? No. Okay, I don't know why it wouldn't autocomplete show date for me. But okay, so now I can do it. But this is, I put in the shebang just to prove to you guys that putting in the shebang wouldn't solve the problem that you were proposing that it would solve, the like command not found. If I take out this shebang and I try and run it, it works because it sort of assumes shell script. So that was a bad example. But this, especially if I was going to be using a different shell like CSH or ZSH, or, you know, because you can do different things in different shells for scripting, or TCSH, you want to make sure that you're telling it exactly what to run. Right. And so the shebang, I don't know why this is sh. I'm guessing it has to do with shell, but exclamation points are always called bang. Hash, it's like HA shebang. Is that, yeah, okay, cool. So shebang. Yeah, after all that shell script fun, it didn't do what I wanted when I took that off, you know, which sometimes it'll say, yeah. But that is why if you try and run, if I just try and run new promise, it's some JavaScript. Let's not even worry about what it is. And we can just look at the first few lines. It's, you know, just basically some JavaScript with promises. If I try and run it, notice it's like, your syntax is totally wrong, right? It's trying to run it as a shell script, and these are not shell commands. So if I want to run this, now the shebang becomes really important. And this is where I can, and I never remember. Have you guys memorized the one where it just finds whatever node is being used on the system? Yeah, neither do I. Oh, yeah, look it up for me. I get to take a drink. It has something to do with env. I think it's like user bin env node. Let's try that.
Not user.
Oh, you think it's like something else bin?
Yeah, because it's not attached to a particular user, right?
Well, the user is just a directory. Looks good. Okay. The user is not the same as users, right? Yeah. Okay, so now if I run it, now it's actually doing stuff. It's a silly file that like considers you lucky if the number of seconds is evenly divisible by 3. So to demonstrate promises. Okay. Okay. Cool. Did that answer? Do you have any other questions on shebang, Kelsey, or do you have any questions, Celeste? Cool. Okay. When to use homemade exception? Okay, I'm just going to do the deleting a test file during the test because that's pretty easy. You just use, there's a command in FS on link. Yeah. Did you try it? It didn't work?
Yeah, I just.
Yeah, but that's basically how you do it. Okay.
Like literally deletes it.
It deletes it. Yeah. It's gone. Yeah, make sure you're using unlinked sync unless you want to dive into the murky world of callbacks. All right. So homemade exceptions. So again, I'm going to speak from a Python perspective because that's what I got right now. Basically, you might want functions in your program to communicate with each other when things go wrong. And so what you can do, and there are a couple ways you can do this. So this is not directly answering your question, when would you use homemade exceptions versus built-in exceptions? This is more when would you use handmade exceptions versus having a function communicate an error in a different way, right? And you could have a function communicate an error using built-in exceptions. So if I go here, so I can say, let's do, okay, so I could say if I have a function, const, let's do read file. Okay, I think I actually want to do, and so I'm not making my own function or my own exceptions, but I'm getting there. I have 7 minutes. Okay, so if I say again, I'm nope. Python, I can like just, I'm fluent in Python. I still like talk like a, 3-year-old in JavaScript, basically. So I'm going to say, I think I'm actually going to, And then I'm going to do a catch. And I'm going to say if, right, you don't do that, you just say catch error. Okay, so I'm going to say if error.code, and let's just look at some error codes. So okay, so enoent. Okay, so they're doing this enoent. My file does not exist. And then, but there might be a different error code, right? And I'm just gonna return. And I say if error code is, what, you are mad. What is, closing curly brace doesn't appear on the same line as, so what's that? It wants the catch to be here. Unexpected spaces after catch. There is no space after catch. After the close, like, oh, here? Okay, I'm gonna ignore you for now. Okay, whatever. So, and I don't like you either, so there you go. So, okay, so if the error code is something else, let's say file not readable. Ah, here we go. No, these are the file modes. E, not dear. Okay. Somehow I want to get a list of these. So I'm just going to say, you know, like whatever file. Right. And I could look up the error code, but it's 1057. So then I'll return. Right. Okay. And so, all right, the reason that I did all of this to answer your question, Celeste, is because when they wrote the read file sync, they threw different errors depending on whether the file doesn't exist or whether you don't have permission to read the file. This is just going to be, you know, I could find this either by doing better Googling or by just testing, like trying to read a file that doesn't have read permissions and see what error comes up, right? And in that way, I can handle the error differently depending on different things, and then I can just have a catch-all at the bottom, right? So the reason that you would want to make your own exception is if you want your functions to be able to communicate in this detailed a manner, right? If you want to say, I am going to run my function, and let's say it's a function that has to do with the database, and if the user doesn't exist in the database, I am going to throw a custom exception that is user doesn't exist. And then when I handle it, I can say, if the exception that I threw was user doesn't exist, then do this. Otherwise, maybe you want to check for a different exception, like database connection down or, bad or something. Then you do something different. And then by default, you just say an error occurred. Call Celeste. Did that answer your question?
Yeah.
Okay. Do you have questions on that, Kelsey? Yeah. 10:59. Yeah, I know, except I'm the one doing phase 2 today. So like I would have given myself all the time I needed to finish if I needed it.